Morning, afternoon, good evening. This is Games Without Chance Moves. I'm Tom Morley. Games Without Chance Moves, games without dice, games without cards, also called Combinatorial Game Theory. These are games with no flipping coins, no shuffling cards, no rolling dice. What I want to do today is look at a very simple case of a game called NIM, which you may have seen or you may not, but we want to take a look at this game. This game will show up in the course several times as a way of not only example of games, but also as a game that's used to analyze other games. So here's NIM. NIM starts with piles of coins. Here we have pile of 3, pile of 2, pile of 1. In this case, 3 piles of coins. Each player must remove one or more coins from exactly one pile. Any pile will do. There are 2 players, the players alternate. So in this case, the first player could remove one of these quarters. The second player might remove both of these nickels. The first player might remove this quarter over here. The second player might remove these 2. And now the first player has no moves because there's no money left on the table. And when there's no money left on the table, you lose. So your object in playing NIM is to be the last person to remove a coin from the table, or in other words, to not be the first person with an empty table. So let's take a look at some simple cases. If there's just one pile on the table, this is 4 coins, one pile on the table, and you're the first player, what do you do to win the game? You take this and put it in your pocket, and you're gone. The other player, there's no money on the table, the second player loses. Doesn't matter how many coins there are. If there's 4 billion coins, put them all in your pocket. Next, most complicated case is 2 piles. With 2 piles, let's take a look at 3 and 3. And start with player number 1. Whatever player number 1 does, say removing a coin over here, then player number 2 does exactly the same thing to the other pile. Now player 1's again, so player 1, say, removes both of these. So player 2 removes both of these. Now player 1 loses. So what this is an argument that's going to come up in the course called the Tweedledum Tweedledee. Whatever the first player does, the second player does it to the other pile. And so if you start off with 2 piles that are exactly equal, you can do that. This says with 2 piles exactly equal, the first player always loses under best play. What if the 2 piles aren't equal? There's 3 coins over here and 4 coins over here. Then the first player removes one of these, and now we're left with a previously solved case. Whatever the next player does, this is player number 2. The player number 1 does the other thing to the other pile. And now, if you work out the parity, it's not the first player that loses, it's the first player that wins, because the first player was the one that reduced it to this situation where the next player to move loses. Okay. Now, so I think there's enough here for you to work out a slightly more complicated case yourself. 3 piles. Actually, using the notation we'll see later in the course, we have a pile of 3, a pile of 2, and a pile of 1. Do you want to be the first player to move or the second player? Let me know. We'll figure it out. Take care.